Okay, so in this activity, I'm going to set up different combinations of identical bulbs, and your goal is to figure out which one or rank their brightnesses. I'm not going to do any calculations. You're not going to be given a voltage or resistance. All you know is that all the bulbs have the same resistance, and we're going to treat everything ideally, ideal wires, etc. Okay, so if you look what you have in front of you, so what we're going to do is go back and forth between the PhET simulator here, and then we're going to look at the sheet that you should have in front of you that has a schematic of what I'm showing in the PhET. So in the first situation, we have resistors 1, 2 in series, and then in a parallel branch R3, and then they're just simply connected to a battery. So in the box here, I want you to rank what their relative brightnesses are. Okay, if there's an equal sign, put an equal sign for there. All right, so I want you to do that right now, and then I'm going to flip the switch, and then we'll talk about it. Okay, so let's flip the switch and see what we got. All right, so if you can tell by the lines of the rays coming out, we see that R3 is the brightest, that's greatest, and then R1 equals R2. All right, so if we were to justify that, we would basically say this upper branch has 2 in series, so their overall resistance to the upper branch is going to be greater than the lower branch. And so if the resistance is greater, it's going to get less current, but since they're in series, they have to share the same current, so they're going to be the same brightness, but less bright than R3. All right, so now let's turn our attention to the next situation. I'm not going to create a new circuit yet. Now we're going to do is we're going to remove bulb 2. So pretend I can unscrew this, but not reconnect the wires. Now I want you to rank their brightnesses again, and then how R1 will change from the original, if at all, and how R3 will change from the original, if at all. Okay, so there's 2 things you have to answer. You have to rank them again. R1, R2, R3, bulb 2 has been removed, unscrewed, so that's going to be the least bright. We know that. And then tell how R1 and R3 will change. That's important. See if you can deduce that. So pause this, and then while I set up things and see if you can make those predictions. Okay, so in order for me to unscrew it, I'm going to just disconnect it right there. So I'm going to press a button. So look at the relative size of their brightness, disconnect, and what do we see? R1 goes out. Okay, so in terms of rankings, R3 is still the brightest, which is equal to R1, R2, and R1, R2 have no current at all. Anticipating that when we unscrew bulb 2, we open up the upper branch, so no current goes through the upper branch, so R1 goes out. Now, did you notice there was any change in brightness in R3? So let me reconnect that and see if you see any change at all. No. Okay, so why didn't R3 change at all? Because it's in a parallel branch, and parallel branches are independent of what happens in other branches. So we would have predicted no change in 3 in that regard. You might say, well, wait, doesn't the overall resistance of the circuit change? It does change, but the voltage drop across this lower branch doesn't change, and this branch still has the same resistance, even if the overall resistance changes. So it's still going to get the same current as before. That's the independence part. All right, so let's look at the next situation. Next situation is, what if I added a fourth bulb in parallel with the other tube? So imagine I had a, I just added a fourth or another branch, R4, that looked like that. Okay, we'd want you to rank them once again, and we can discuss whether 1, 2, 3 would change at all. So pause and make your predictions, and then start it back up, and we'll see what happens. Okay, so you see I've added a fourth one in parallel. So let's make sure we understand why we have 3 branches. We're coming out of the battery, splitting 3 different ways, come back together, and then to the negative terminal. Okay, so if I close this, what do we see? R4 and R3 are the same brightness, and 1 and 2 are the least bright. So basically adding R4 in parallel to the others didn't change the others. because they're independent branch, and adding a new parallel branch just gives us more overall current, but doesn't change the current in the individual branches. So R4 has the same resistance as R3, so it has to have the same brightness. So the important lesson here is when you add resistors in parallel to other branches, it doesn't affect the other branches, and it will be the same brightness as any other branch if the resistance is the same. Now when I say that, what's important about that is there's nothing in series before you get to the branches. Okay, now let's look at the next situation, which is to me the most important because it's an interesting combination. Okay, so we have R4 is in series then with the battery, and then it splits into two branches. One branch has R1, R2 in it, and then R3 in the second branch. So go ahead, take your time, and rank the brightnesses, and I'll set them up. So here's our setup. This is R4, R1, R2, R3. Unfortunately, I can't label them very easily, so you just have to keep track of them using your schematic. So what did you predict in terms of rankings? Let's turn it on and see what we got. Okay, so not immediately obvious, but we should see R4 is the brightest, then R3, then R1 equals R2. So these are the least bright. So we want to be able to explain that. The simplest explanation is this. R4 is in series with the battery, so all the current must pass through it. Okay, since it gets all the current, it's going to be brightest. And then when it gets to the branch, it splits up. And we've already seen in a previous example, this branch, R3, should get more current than R1, R2, simply because they have high resistance. So that's the second brightest. And then these guys will be the same brightness because they're in series with each other, but they get half the current as R3. Okay, so that's an important problem. Now, a variation on this is what happens if we unscrew certain light bulbs. So let me go back to this. Now we're going to see what happens for three different situations. Okay. What if R2 is removed? In other words, we unscrew light bulb R2. We take that out and don't reconnect. Rank their brightnesses and then state how R1, R4, and R3 will change, if at all. This is, to me, the most important problem of them all. If you can get this consistently, then you're on the right track. So pause and see if you can figure it out. Give yourself about a minute or so to work this out. Okay, so let's start it up. There's what we had originally, and I'm going to disconnect with R2. Okay, so we should have expected that R1 goes out, so they both go out. Maybe less expected is that R4 and R3 are the same. Okay, why is that? Well, if you look, since we broke the circuit here, there is no more upper branch. We have a series circuit. These two are in series with each other. There is our one loop. There is no upper loop anymore. Since they're in series, they have the same brightness. Now, in terms of change, R1 clearly decreased. It went from something to nothing. What you might not have noticed is how R3 and R4 changed. They both changed. They both change subtly. Let's look at R4. R4 has these little brightness, and if I disconnect, notice it went down. So R4 got dimmer. If you want to know why R4 got dimmer, it's essentially because we took out, it still gets all the current, but since we took out this branch, the overall resistance of the circuit went up. Whenever you take out a parallel branch, resistance goes up. If the overall resistance went up, then the overall current went down. So while 4 still gets all the current, it gets less current than before. Now, if we look at what happens to R3, again, here it is. When I disconnect, notice it gets brighter. So 4 went down, 3 went up, so they got the same brightness. The simplest explanation of why R3 went up is simply not sharing as much current as before. Even though the overall current did go down, it's not sharing anything with this branch, so it's going to get more current than before. All right, now let's look at the last situation here. Okay, so R2 is restored as before. Okay, so everything is like it is. And now we're going to remove R3. Just unscrew it. Do the rankings and write what the changes are. Okay, so here is the original circuit with 4 brightest, then 3, 2, and 1. Now I'm going to disconnect 3. And what do we see happening? Obviously 3 goes out. And notice that 4, 1, and 2 are the same brightness. Why? Well, they're in series with each other. Because we took out the lower branch, we have 3 bulbs in series. And very similarly to the previous problem, R4's brightness went down because the overall resistance of the circuit went up. And R1 and R2 got brighter simply because they're not sharing with the lower branch anymore, so they get all the current. Okay, so what I would like you to do to show that you've done this exercise, right, hopefully in good faith, is I'd like you to upload your answers to Schoology from this sheet. Whether they're right or not, it's not the issue. I just want to show that you tried this in good faith with your rankings and your changes. If you have any questions, make sure you ask in the assignment when you upload, and I'll address as best I can.